Hey, welcome back. I'm going to do another teardown of this IBM server. And here's another component that I have several of. I think I have 4 or 5 of these. And they're not all identical. They're kind of configured a little different, each one. But this, as far as I could tell, is power distribution for the server. And I'll explain why I think that. I haven't even opened it up to look at it yet, but let's have a look at the nameplate first. This thing is massive. It is, let's see here, 18 inches wide. It fits on a 19-inch rack. 17 inches deep, and it is probably 1 inch high. Just yeah, it's exactly 1 inch. So it doesn't take up very much space in the rack, but probably has a real important function. It has 4 connectors that I just happened to hack off when I was in my mad rush to get this thing moved. Instead of trying to unscrew everything, I just hacked off the cables on some of these. This is a power connector, and we'll get to that, and we'll put that aside for now. Let's look at the spec plate on this thing. This thing has cross flow ventilation. It's cut for ventilation on the sides only. There's no other ventilation on it, back, front. It's just on the sides, both sides. So it's a cross flow ventilation for cooling. Let's flip it over. It weighs quite a bit. It's maybe 5 or 8 pounds, something like that. Oh, we got this upside down. Here, let me move the camera so we get a better look. Okay, I don't know how well this is going to show up on the camera, but I'm going to go through it anyway. So again, the manufacturer is Delta Energy Systems of Germany, made in Slovakia for IBM Corporation. Made in the Slovak Republic. BDP, this is model number BDP-EP. I guess this is power distribution. That's what they call in this power distribution. It has an input of 350 volts, 100 amps maximum, and then it has 10 outputs from J1, 2, 3, 4 all the way to 10. And it specifies here on each output, I guess these are, it's kind of a protection relay or protection circuit that regulates how much power can go out. You know, when you're dealing with 350 volts at 100 amps, you have to regulate it somehow. You just can't let it flow out freely. So the first 5 are rated at 350 volts, 6 amps full load. 6 amps, 6 amps, 6 amps, 6 amps, 6 amps. And they have a 7.2 amp maximum trip current. So this thing will not put out more than 7 amps, 7.2 amps before it trips. And it has 160 microseconds maximum trip delay. And it has 100k amps max interrupting. So if it was a dead short, it would be 160 microseconds before it tripped. And then these 5 are at 6 amp loads, and these 5 are at 8 amp loads. So we have 350 volts, 8 amps full load, 9.5 amps maximum trip current, 160 microseconds maximum trip delay, 100k amps maximum interrupting. So right here, let me zoom out a bit. Oops. On the back side, we have our input power connector. This is going to take in the 350 volts, 100 amps, these connectors here. And then we have some pins for data and control. This plugs back into a backplane. I don't think I have the backplane anymore. I think I destroyed it and salvaged it. But on the opposite side, we have our 10 outputs, and each outputs, this one's J06, J05, J4, 3, 2, 1, and then these are the other outputs, the high current ones, the 8 amp outputs. This one's J10, There's a little LED here to say power is good. It says BPDD good. No, it's BPD good. I don't know what BPD stands for. Balanced power distribution? Maybe? I don't know. Somebody else would know. So let's get the lid off this and have a look. But first, let's have a look at one of these connectors. These are, I think they're proprietary IBM connectors. They have the address. This one came off of P10, which is the one that was just down here. I took it off. It's got 4 cables out, and it's got kind of a split connector here. One side we have data and control, and the other side we have 6 power pins. And these are all, everything's gold plated, of course. They don't mess around with tin plating. Just want to have a look at one of these connectors. Tear down one of these connectors. I scrapped a lot of these, and come on. Flathead screws. Who uses flathead screws in 2008? Okay. So obviously the connector has locking screw locks. So once this is pressed in, you turn it and it locks it in, and these are tightened, they're torqued down. There is metal brought out to the front for grounding. I don't know if you saw that here. Push this aside. You can see that the grounding strip comes in full contact with the case, so there's no RFI leakage out of these whatsoever. You open them up, remove the plastic case, you have your 2 locking screws, and everything's fully shielded in a metal case. They went to great care to ground the ground. These are all coaxial power lines. They're all shielded. Everything's 100% shielded. So we got 4 shielded lines. Okay, let's open this up better. A screwdriver. Take the shielding off. Just to assemble these things was been time consuming. Let's pull all the shielding off. And then there's another layer of foil under there just to make sure. So we have 4 cables. 2 of them were signal and control, and 2 of them are power. So I got a plus negative here, and a ground, looks like it might be a ground, and a plus negative here, and it looks like it might be a ground for the shielding. So these 2 are 350 volts, 350 volts. There's probably there's redundancy built into these. They have 2 power lines, 2 ground or negative, 2 positive, and then 2 ground shields. And the rest of this is control and data, kept separate. Throw this away. So you can see they're not cheap connectors. They're not your run-of-the-mill. I don't know if you can even buy these on the open market. They're probably proprietary just for IBM to use on these, on their systems. Very high quality connectors, all gold plated. I didn't see any marking, brand marking on this, but Foxconn usually does a lot of IBM stuff. So let me remove these other 3 connectors and then we'll pull the lid off this. 5 screws. This huge aluminum plate comes off. I hope. No, it doesn't. I have to remove these as well. So I don't know if I have a... Okay, remove the cover. And I notice they have RFI gasketing here. This is a gasket, and it's a foam gasket, and it's wrapped with a metal woven cloth for RFI shielding. And they got one on the top here just to keep everything. There we go. Something stuck inside it. Insulating sheeting on an aluminum cover. And inside we have a lot of power management going on here. Let's get a camera set up closer so we can see what's going on. So right on the input we have our connector, our 350 volts input, 100 amp max, and we have some data lines here, and then it's completely split off onto all these fuses. 2, 4, 6, 8, 10, 12, 14 fuses. These fuses here, oh, this is right here. Fuse 1 to 6 is 8 amp, 600 volt fast acting high brake. Fuse 1 to 6, 1 to 6, 1, 2, 3, 4, 5, 6. So these are 8 amp fuses. 0, 8, 9, 11, 12, 14, 15, 17, 18. Those are 12 amp fuses. So we got all our fusing right at the inputs, and then from there it goes to these regulators. Let's pull off a heat sink here. Remember, we have cross-flow ventilation or cross-flow cooling on all these. So what this is, this is a 28N50. 28N50. I'm going to go look that up. Be right back. So the 28N50 is a 28 amp 500 volt MOSFET. It's actually called a UNIFET, and these MOSFETs are unique in that they have a very low on RDS of about 120 milliohms. Very low on resistance, and they're probably using this in a buck boost kind of thing. There's no transformers in here whatsoever. There is a 0.015 ohm shunt, and there's a little ferrite bead in here just to kind of keep the RFI down. But there is no other inductors on this board. It's all switching from MOSFETs, and then there's capacitors on the output. So we have input fusing, goes to the MOSFETs. We have a little bit of a control here. The sense probably. This is probably sensing, and then we have some opto isolation to keep the control data away from the 350 volts, or the return data. Over on this side, we got a little power supply, and you can see it's a 4.7 microfarad, 450 volts. Little MOSFET here, and transformer. This is probably supplying all the opto isolators with a little bit of power so that they can operate isolated from the 350 volts. Let's turn this around. Let's have a look at this channel. This is one of the lower current supplies. So this is probably the 6 amp one. A lot of data lines coming in. On the output they have a little bit of filtering, 4.7 at 450 volts, a couple of line caps, maybe one more attempt at monitoring. This little chip here is probably monitoring the outputs, or maybe this is receiving the data back from whatever device is under control, because there is data lines in here. These some of these are data lines, and this might be a transceiver maybe that goes back, sending data back and forth to the controller. So it's got a date code of 35 of 2008. That's when this was built. So we got six lines of 6 amp output, and then we got 4. Am I right on that? We've got 10. Yeah, my mistake. There's 6 lines of 8 amp. Sorry, 6 lines of 6 amp, 4 lines of 8 amp. And these look like they might be dual 8 amp. That's probably what they are, because they have 2 sets of transistors instead of 1. There's 2 sets of transistors on each of these channels. So there's probably 2 lines of 8 amp. 2 lines of 8 amp, 2 lines of 8 amp, 2 lines of 8 amp, 1 line of 6 amp, 6 amp, 6 amp, 6 amp, 6 amp. So that's what's going on here. And with each 2 lines we got 2 transceiver chips, it looks like. I don't know what chips those are. I'll read the number off of it. It's a Max 3071. So I think that is a RS-232 transceiver. I'm not sure. I'll have to look that up. So that's all there is to it. I'll pull the board out and show you the back side of it. Okay, so I think I got all the screws out. Yeah. So we got an insulating sheet and the steel bottom. Again, this is very heavy gauge. I think I measured on the other video. It was 1.3 mil. It's quite heavy. Let's have a look at the back side of the board. Essentially there's nothing. It shows all the power input. Here's the power input, 350 volts. This is probably ground. Let's see here. Yeah. So positive, negative, I'm assuming. I don't know what that is. This might be chassis ground. But it's all laid out. Dual channel, dual channel, dual channel, dual channel, single channel. So harvesting parts off this, you're going to get some good MOSFETs. A lot of good heat sinks. All of these are good for salvaging. Fuses, I don't know if you want to salvage the fuses if you have a use for these kind of fuses. These are really a specialized high voltage fuse. Capacitors, I'm not really big on salvaging these kind of capacitors. I don't use surface mount. I suppose I might capture a few of these. A lot of opto-isolators. These are just Jelly Bean 817 opto-isolators. So, you know, a lot of good surface mount opto-isolators there. There's, I don't know, probably 2, 3, 4, 5, 6, 12, 18, 24. You know, you get the idea. There's 50 some isolators on this board. Other than that, it's pretty simple. You know, being it's controlled by has a microcontroller to watchdog all this and control it and monitor it. But that is one of the power distribution boards. Everything's gold plated. connectors, both sides. It's a good sized board. I'm sure it's not cheap to build this. Quite a bit of dust on this one. You can see his cross flow, so the air was going this way. The side's got more dust on it. Alright, so that's about it for this one. Let me know in the comments what you think of the teardowns, if you want to see more of this kind of stuff. Like I said, I got a mountain of it behind me, and we can get into this, tie into this, and show you off some more of this stuff. I think it's interesting the way they designed this for redundancy and reliability. A lot of interesting stuff here. We've got some 1% resistors stuck in here. I don't know if they're sensing there, probably voltage sensing. This, for example, is 5.11 ohms, 1%. A little switch mode power supply is pretty cool. Alright, so thanks for watching.